Hello everyone, welcome to RadarNexus. This is the first video on this channel where I will be trying to explain radar technology and share what I have already learned about this technology and also other related topics, engineering topics that are related to radar. And Also, the goal of this channel is that I can learn alongside with you about radar and then come here and share what I have learned. So, if you have ever been curious about how airplanes are tracked, how weather forecasts are made, or even how some cars know uh, the objects around them and when they are coming close to them, then you are in the right place because the secret behind all these technologies are radar. Radar is not only used in the most common use of radar is in weapons to detect airplanes or detect submarines, but also it has so many applications other than that, which we will know later in the video. So for today, I would like to start from the complete beginning just to know what's the simple working principle behind radar and what does the word radar stands for. So let's start. So as you will know right now, the name says it all. So the word radar itself, it stands for radio detection and ranging. So as you can see here, from just looking at the name, you can already understand the purpose behind radar and the working principle behind radar. Radio, it comes from radio waves, which is a part of the electromagnetic waves. Uh, later videos, I will be explaining what are electromagnetic waves and dive more in depth to them. But for now, you can just know that radio, it comes from radio waves, which is part of the electromagnetic spectrum. Detection. So radar detects things, and it can identify things and detect them. Ranging. Ranging means uh, can know how far these things that have been detected away from the radar. So as you can see, it's very simple: radar detection and ranging. And by understanding these three words, you can already understand a lot of things about radar. So let's go a little bit deeper. So what does it make it so special, and what does the radar actually do? So as you already know that we have so many sensors. We have cameras, we have lidars, which are lasers, work based on the light, laser scanners. We have ultrasonic sensors, we have infrared sensors, we have heat sensors. We have so many sensors. So why the hell anyone would use radar? So radar can measure four things. Let's say four. Okay. First of all, it can measure the range of the object. So if we imagine here that we have 3D space and we have here our radar and we have here our object. So radar can measure how far away that object from the radar. And it also can measure something called uh, horizontal. Let's say it's, okay, let me say it like this. It's called azimuth. What is azimuth? Azimuth is basically the horizontal angle. So if we came down here into that 3D space, azimuth will be that angle. And let's call it phi. So phi is azimuth and it is the horizontal angle. R is the range of the object. Also, radar measure one more thing. It measure theta. Theta is the elevation angle, and it's the vertical angle. Okay, so it measures the range, it measures the horizontal angle, and it measures the elevation, which is the vertical angle. But is that it? Does this make Radar special? It doesn't, because if we are going to talk about the three things, I think LiDAR works much better than any other sensor to measuring these three things. And it can tell you exactly where any object in the 3D space. What radar makes it really special that it can measure one more thing. And I want you to remember this because it's one of the most important things about radar. It can measure velocity of the object. So if you understand this, I think I want it to be ingrained in your brain because velocity is one of the most important things that makes radar special than other sensors. Radar works, what we will know later on in later videos, on the using electromagnetic waves, and by utilizing something in physics called the Doppler effect, radar can determine the speed of the object. Okay, so now we said that the radar can measure range, horizontal angle, vertical angle, and velocity. Also, is that it? Does radar doesn't have any more advantages? Radar have also the advantage of that it can work in any lighting condition. Radar is not affected by darkness, by bad lighting. It can work in any other lighting condition, in any weather condition. So it can work in heavy rain, heavy snow, where other sensors will fail miserably, like cameras and LiDARs. So, yeah, just to recap: range, horizontal angle, elevation, and velocity. This is the advantages and the capabilities of the radar. So now let's move on to understand the components that are inside the radar. How does it work and what are the components that exist inside the radar? The radar starts, everything inside the radar starts by something called the wave generator or the signal generator. So first of all, the radar generate a signal with a specific characteristics. The specific characteristic, this word is very deep and we can make a whole course about it, but let's just say for now it's specific characteristic. And this wave go through a mixer and it also goes something called transmitter. Transmitter is another part of something called antenna. So the antennas consist of transmitter and a receiver. So first of all, it goes through the wave generator, and the wave generator generates a signal, and the signal is transmitted using a transmitter. So here we have our transmitted signal or our transmitted waves, which will hit an object. Let's say this object is a plane. Any object can work also with radar. What happens when the radar generates these waves and it hits an object? This object will act uh, as something like very interesting. This object now will act as like standalone radar. Yes, and if you understand this, you will understand actually how radar works on a high level. So when these red waves hit the object, this object will act actually as another radar, and it will reflect these signals or waves. And then it will be received by the receiver. So wave generator, transmitter, and then a receiver. These reflected waves will be received by the receiver. Okay. Now what will happen is we already know what are the specific characteristics of this transmitted signal, correct? Because we already know that it's generated by the wave generator, and it will go through here the mixer. The mixer here will be waiting for the reflected signal, which will come here through, and it will reach to the mixer. So the mixer now have the Rx and the TX, transmitted signal and the received signal. What the mixer will do is that it will mix these two signals, and then it will like generate another signal here, which is called the IF signal, or the intermediate frequency signal, or whatever signal. It has so many names in so many books. But let's just say for now it will generate a signal. Now, by comparing the characteristics of the transmitted signals and the characteristics of the received signals, we can extract so many things about the object that have been that these waves have hit. Because when these waves hit that object, the object will distort these waves and reflect them back to the radar. This distortion that happens into these reflected waves, later on we will depend on them in order to measure or extract the information that we talked about here in this slide, the range, the horizontal angle, the vertical angle, and the velocity. So by analyzing the received signal and the transmitted signal, we can go here to this block, which is called a signal processor, which will process this mixed signal. And by processing this mixed signal, we can extract all this information about the object. And now we know how far away this plane, and how what's its height, what is the vertical angle, what is the horizontal angle, and what is its velocity. After that, we will reach to this block, which most of you already know, the data visualization. I think most of you have already watched movies where you have this screen like a circle, and it looks like this. And then you have like an object here, and keep beep 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 beep. And then this is the data visualization block where you will visualize your detections. And in that case, our detection is a plane. Okay, now I think we know what does the radar do. Measure range, angle, range, elevation, azimuth, and velocity. And we knew now what are the components inside the radar and how does it work. This is all in a very high level, so we will go in depth later on in other videos. So let's move on to know what are the applications of radar, what are the applications that use radar. So radar is everywhere, basically, and now you will know what are these applications. First of all, radar is heavily used in the weather forecasting because, as I said, the radar here transmits signals, and these signals hits objects, and then these objects reflect back the signals. So imagine here if we have like like what's called like a cloud. I don't know how to draw a cloud, but let's say this is a cloud. And these transmitted signals hit that cloud, and then the cloud, of course, as we said, it will reflect back again these signals that will be distorted by hitting the cloud, and by extracting the like Rx and the Tx, and having here the mixed signal, we can know what are the characteristics of this cloud. Is this cloud ready to rain? This cloud doesn't, there is no much clouds in the sky, and so on. So it can be used in weather forecasting. Another application, famous application for radar is military applications. I think you already know now by now what is called the Iron Dome, where it's like a very big radar, like in the size of a truck, and you can put it on the borders of your country, and this radar will detect any coming missiles, and by this radar here will detect any coming missiles, and based on that, this Iron Dome will send another missile, and it will destroy these missiles that are trying to attack the country. This is the whole Iron Dome concept, and so many other applications that are used in military. And where I am working in the automotive industry, where we can put here radars in the on the edges of the radar of the car, and these radars can detect objects around the car. These objects can be passing like pedestrians, or can be other cars, or can be cyclists, or it can be anything else. It can be like cars on the road. So we can use radar in the automotive industry, and of course in the marines, in ships, and in also submarines. Another use of radar is traffic radars, traffic monitoring. Of course, some of you now have already have fines because speeding, and as we said here before, that velocity is one of the things that radar can measure. That's why you have been fined when you are speeding. Okay, and also like aviation, like with airplanes and traffic monitoring, but in the skies basically. So here it does the same thing, but in the sky, where airplanes can detect other airplanes, and also the airport can detect when is an airplane is nearing the airport. That's why they can prepare for it. Other two applications here for radar that will be, I think, interesting for you, and probably you didn't hear about them before. Health monitoring. Yes, radar can be used for health monitoring. For example, measuring your heart rate, measuring your breathing rate. Um, all these things can be measured by radar. Again, back to the basic working principle of radar. Radar hits an object. Let's say this object this time will be a human, and it will hit this object here, and the object will reflect back the waves, and these waves will be distorted. So, based on that distortion in the wave, we can extract your heart rate, we can predict your breathing rate, and all these indications. And of course, as I said, like radar can measure the velocity, so the velocity of your chest moving up and down because of breathing can be measured by radar. Another application is people counting, people tracking, people detection, whatever you want to call it. So in a lot of security applications, radar can be used inside buildings to track people, or for example, in gardens, radar can be used to track any intruders. And yes, um, there are so many other applications other than these that the one you see. For example, I have been working in my master degree in radar application inside the car for interior sensing. So yeah, it works here same like this, for health monitoring and for people detection inside the car. So yeah, but these are mostly the applications of Radar, and as long as you understand the working principle of Radar, you can, of course, decide later how you can use it. Okay, everyone, I think we can uh, end it for today. I think this is enough for the first video for RadarNexus. And so I want you to do a couple of things. First of all, I want you to subscribe and like tune in for other videos because I have a lot of ideas for a lot of content to explain about Radar. More in-depth explanations will come soon. So I know today have been very high level, but I intend with this channel to go in depth inside the topic and try to understand things in depth. So I want you to comment with any questions you have or any suggestions for future videos or requests, and yeah, I will try to look at those. Okay, thank you everyone.